display the hex digits 0 to F on a 7-segment LED interface with an appropriate delay in between each and every digits. Okay, so this is what the program is. So in this for to implement this program, so we'll be using the 7-segment display which is there in the microcontroller board. So the 7-segment display is nothing but, so there are 7 LEDs. So there are 7 LEDs which are called as the segments, and that will be connected, in the form of 8. Okay, so the 7. So before going into the program explanation, so first let's know what is the 7-segment display. The 7-segment LED display is an output device for displaying alphanumeric characters ranging from 0 to F, so which is nothing but hexadecimal numbers. It contains eight it contains 8 light emitting diodes LED segments arranged in a special form. Out of the 8 LED segments, 7 are used for displaying alphanumeric characters and 1 is used for representing the decimal point DP. So as shown in the given figure. So this is how the 7-segment display looks like. So here you can see there are 7 segments. So here the hex digits from 0 to F will be displayed in these 7 segments, and we have a DP segment here. So basically this DP segment is used to display the decimal point numbers. So if there are any decimal point numbers, so then this DP segment will be activated. So basically there are 7 segments. This is arranged like this. All the 7 segments are arranged like this. So here for each and every segments there is a name given. Okay, so this segment will be called as A, this segment will be called as B, and here we have C segment, and here we have D segment. So this segment is called as E, and this segment is called as F, and the middle segment is called as G. So this is how the 7-segment display is associated with alphanumeric alphabets. So the LED segments are named A to G, and the decimal point LED segment is named as DP as shown in the above figure. The LED segments A to G and DP should be lit accordingly to display numbers and characters. Okay, so here to display the numbers as well as the characters, the corresponding segment should be lit. So then only the numbers can be displayed. So there are 4 multiplexed 7-segment displays. So ranging from unit 8 to unit 11 on the microcontroller board. So as I told, in our lab, so we are using LPC2148 microcontroller. So in that microcontroller, there are 4 7-segment display. So while the first 7-segment display is called as unit 8, second 7-segment display is called as unit 9, third 7-segment display is called as unit 10, and the fourth 7-segment display is called as unit 11. So there are 4 7-segment display in LPC2148 microcontroller board. Each display has 8 inputs. So as I told, so there are 8 LEDs which are associated in the 7-segment display. In that 8 LEDs, 7 LEDs or the 7 segments are called as the 7 segments are ranges from A to G, and the another one is called as DP, decimal point. So basically to display the decimal point numbers, this DP LED should be lit on. So the port lines, so here again we have a port lines which are associated for each and every unit in the microcontroller. So based on that port line only we can use the 7-segment display. So here the port lines ranges from port 0 28th pin to port 0 31st pin, which means that, as I told, there are 4 LED segments. There are 4 LED segments in LPC2148 microcontroller. The first unit 8. So the unit 8 is associated with the port 0 28th pin. Unit 9 is associated with the port 0 29th pin. Unit 10 is associated with the port 0 30th pin. Unit 11 is associated with the port 0 31st pin. So as I told, so all these 4 7-segment display are associated with the port pins, and all these all these 4 segments are comes under port 0 of the microcontroller. So basically to display the hex digits, either you can use one display or you can use all the 4 display in the program. So the port lines, so then the port lines, port 016 to port 023 are used as the segment lines for the for the 8 digits, or for the 8 segments. Okay, so as I told, there are 8 segments. So the 7 segments are associated with A to G, and the last one is called as the DP segment. So here you can see in the below table, so the selection of 7 segment display. So as I told, so there are 4 port lines which are associated for all the 4 7 segment display. So first unit is associated with the port 028th pin. Second display is associated with the port 029th pin. Third 7 segment display is associated with the port 030th pin, and the fourth 7 segment display is associated with the port 031st pin. So here you can see one is represented across the 20 in the first row. One is written across the 28th pin, and all zeros are represented across the other segments or other port lines. So which means that here only unit 8 will be selected. So if you represent 1000, unit 8 will be selected. So here in the second row, if you represent 0100, which means that this port 029 pin. So the port 029 pin is associated with unit 9, the second 7 segment display. So that will be selected. So if you represent 0010, then unit 10 will be selected. And if you represent 0001, unit 11 will be selected. If we represent all 4 ones, so if you represent 4 ones, then all the 4 units will be selected. So as I told, so again port lines are associated with the segments which are in the 7 segment display. So there are 8 segments. So here you can see there are 7 segments will be arranged like this. 7 LEDs will be arranged like this. So here you can this segment is called as A, this segment is called as B, and we have C segment here, the D segment is here, E segment is here, F segment is here, as well as the middle one is called as the G segment, and also the last one is called as the DP segment. So again, to activate these segments, again that should be activated to the port lines. Okay, port numbers. So again, all the 8 segments are associated with the port 0 of the microcontroller. So let's see the pin number which comes under port 0. Segment A is associated with the port 016 pin. Segment B is associated with the port 017 pin. Segment C is associated with the port 018 pin, and the segment D is associated with the port 019 pin. Then we have a segment E. Segment E is associated with the port 020th pin. Segment F is associated with the port 021st pin. Segment G is associated with the port 022nd pin, and the last one is a DP. DP is called as the decimal point. So if you want to activate that, then that should be activated through port 023rd pin. So these are the various pin numbers which are associated for all the 8 segments. So let's see how to display the hexa digits ranging from 0 to F. So if we want to display 0 on the 7 segment display, then all the segments from A to F should be lit on. So and G should be off. Okay, so we need to activate the segment A, we need to activate segment B, we need to activate segment C, and we need to activate segment D. We need to activate segment E, and we need to activate segment F, and we need to switch off the segment G, because in 0, so we don't have the middle line. Okay, so the G segment should be lit off. So that's why, so we need to activate the 6 segment except G. Okay, so that's how we need to display 0 on the 7 segment display. Likewise, if you want to display 1, then B and C should be activated, others should be, so others should be in non-activate state. So then if you want to display 2, then A, B, D, and E as well as G. So we have the middle segment here. So G segment should be lit on. So this segment should be selected. So to display 3, segment A, segment B, segment C, segment D, and segment G should be selected. And to display 4, segment B, segment C, segment F, and segment G should be selected. To display 5, we need to select segment A, segment C, segment D, segment F, and segment G. And to display 6, we need to select segment A, segment C, segment D, segment E, segment F, and segment G, except segment B. If you want to display 7 on the 7 segment display, we need to select segment A, segment B, and segment C. So we need to select only these three segments to display these, to display 7 on 7 segment display. Next, if you want to display 8 on the 7 segment display, all the segments should be selected, okay, including the middle one, G segments. All the segments should be selected. So if you want to display, if you want to display 9 on the 7 segment display, then we need to select segment A, segment B, segment C, segment F, and segment G. Then coming to the alphanumeric characters, so we can display alpha numbers from A to F. So if you want to display EA in the 7 segment display, then we need to select all the segments except D. Okay, except D, we need to select all the segments. Then only A can be displayed on the 7 segment display. If you want to display B, then segment C should be selected, segment D should be selected, segment E should be selected, as well as the F and G should be selected. If you want to display C, and again we cannot display uppercase B in 7 segment display, we can only display the lowercase b. Okay, so then if you want to display C, then segment A, segment D, segment E, and F should be selected. If you want to display D, again uppercase D cannot be displayed in the 7 segment display. We can display the lowercase d. So if you want to display the lowercase d on the 7 segment display, then we need to select segment B, segment C, segment D, segment E, and segment G. Then if you want to display E on the 7 segment display, so we need to select segment A, segment D, segment E, F, and segment G. Then at last, if you want to display F on the 7 segment display, then we need to select a segment A, segment E, segment F, and segment G. So this is how we need to select the segment, or the segment should be selected to display the alphanumeric characters ranges from 0 to F. And one thing you need to keep in mind that we cannot display uppercase B and uppercase D. So we can display the lowercase b and t on the 7 segment display. So this is how we need to select the segments to display the characters on the 7 segment display. So this is all about the 7 segment display. Then coming to the applications of 7 segment display, the 7 segment display are used in various applications like digital clocks, clock radios, calculators, wristwatches, speedometers, motor vehicle odometers, radio frequency indicator, etc. So these are all the various applications of 7 segment display where the 7 segment display are being used. Okay, so this is a microcontroller which we are using in our lab. So this is LPC2148 microcontroller. As this is the 7 segment display interface. So here you can see this is a 7 segment display interface. You can see there are 4 display. There are 4 displays which are connected serially like this. So this is display unit number 8. This is display 2 unit number 9. This is display 3 unit number 10. This is display 4 unit number 11. So this is the IC which is connected to the interface of LED. Then here we have 4 switches, okay, on and off switches. So here if you want to on all the LEDs, or on if you want to on all the LED display, then you need to push the button upwards. Then if you want to off it, then you need to push the button downwards. So this is how you need to activate the LEDs. So basically this is the LED interface. This is the 7 segment LED interface that is available in LPC2148 microcontroller. Okay, we don't need any hardware. So in the previous programs, we need peripheral components like DC motor and stepper motor to execute the program. But here, the 7 segment display itself is interfaced in the board. So no need to connect any peripheral devices to the microcontroller. Okay, fine. So next, let's see how to activate the pins and how to write the pin configuration for each and every digits or characters that need to be displayed on the 7 segment display. So as I told, there are 4 units in the LPC2148. So unit 1 is associated with port 028 pin. Unit 2, so the first display, that is nothing but unit 8. So that is associated with the port 028 pin. This pin should be activated to display the hexadecimal digits on the display 1. So then port 029 port 029 pin is associated with unit 9, the second LED display, 7 segment display. And the third one, so port 0 30th pin should be activated to display the alphanumeric characters on the third display, that is unit 10. So then port 0 31st pin should be activated to display the alphanumeric characters on the fourth 7 segment display. So these are the 4 pins that are associated with all the 4 units which are there in the microcontroller. Then each and every segment should be activated using the port pin. So here segment A is activated through port 016 pin, segment B is associated with port 017 pin, segment C is associated with port 018 pin, segment D is associated with port 019 pin, port 020th pin should be activated to lit on the segment E. Then port 021 is associated with the segment F, port 022 is associated with the segment G. Then if you want to lit on, so if you want to on the DP LED, then port 023 should be activated. So these are the various port pins that are associated with the 7 segment display. So register configuration to activate all the 8 pins. So basically to set the direction, so to set the output direction, then we need to activate all the 4 pins. So we need to activate all the 8 pins. Okay, 8 pins means 7 pins are associated with the 7 segments, and the last one is associated with the DP LED. So this how, so if you want to display the hexadecimal digits, we need to set the direction first. If you want to set the direction, then we need to activate all the 8 pins. Okay, after that and also we need to clear the output, to display the next character. To display the next character, previous output should be clear, which means that we need to use input output clear instruction. So even in that time we need to clear the output pins using this register configuration. Okay, let's see how to activate the pins by using this register configuration. Let's see how to write the register configuration to activate all the pins. So as I told, so this is how the 7 segment display looks like. So there are 7 segments which are connected like this, and the 8th segment DP segment will be at the bottom right corner. So here, as I told, there are 32 pins. So there are 32 bits or 32 pins in port 0. Port 0 contains 31 pins. So as I told, all these segments comes under port 0, as well as these unit port numbers. Even this comes under port 0. Okay, so port 0 consists of 32 pins, ranges from 0 to 31. Okay, 0 to 31. Here, as I told, for 16 pin is associated with A, 17 pin is associated with B, 18 pin is associated with the C, 19 pin is associated with the D, 20th pin is associated with E, 21st pin is associated with F, 22nd pin is associated with the G, and 23rd pin, port 0 23rd pin. So all these are port 0 numbers, ranges from 0 to 31. Here the 23rd pin is connected to DP, and also 28th pin is connected to the first display unit 8, 29th pin is connected to the second display unit 9, 30th pin is connected to the third 7 segment display, that is unit 10, and the last one, fourth display, is connected to 31st pin, so that is nothing but unit 11. So here, so if we want to activate all the segments, all the 7 segments, then we need to write one across A, one across B, one across C. Likewise, we need to write one across D, one across E, one across F, and one across G. Because if you want to activate all the pins, all these should be activated. So if you want to activate all this, then we need to write 1, and we need to write a 0 across all other pins. And also we need to write 1 to display the we need to activate the display, 7 segment display. So that's why under unit 8, 29th pin, 29th pin, 30th pin, and 31st pin, we need to write 1. So if we write 1 across all these pins, then all the 4 displays will be activated, which means that you can display the alphanumeric characters on all the 4 7 segment display. So this is how you need to. So here 4 ones constitutes 16. 16 is represented as F. Then we have 4 zeros. So that is nothing but 0 will be represented. Then we have 0 triple 1. 0 triple 1 is the binary representation. If we convert that to hexadecimal, then 7 is the hexadecimal representation. Then we have 4 ones. Again, 4 ones is represented as F in hexadecimal. Then we have 0 across all other pins. So what's the register configuration to activate all the pins until the rest? So we have F0 0x F0 7F 4 zeros. So this is the register configuration which we need to use to activate all the segments in the 7 segment display. So let's see how to activate 0. So how to display 0 on the 7 segment display. So as I told, so this is how the 0 looks like in the 7 segment display. So here all the segments are in on state except G segment is in off state. So that's why you need to represent 0 across G. And also we are not using DP. So again we are using 0 across DP here. So you can see here, you can see we are representing 0 across DP, as well as we are representing 0 across G, and all other segments should be on. So that's why I'm representing 1 across all the 1 across 16 pin, 1 across 17 pin, 1 across 18 pin, 1 across 19 pin, 1 across 20th pin, and 1 across 21st pin. So all the segments should be displayed except G. So that's why I've represented 0 to G segment and once across all other segments. And I'm displaying this 0 number on all the 4 displays. So that's why I have represented 1 across all the 4 units. So 4 ones constitutes F in the hexadecimal. Then we have 4 zeros. So 0 will be represented. Then we have 0011, 0011 in binary. So if we convert that to hexadecimal, then it will be 3 in hexadecimal. Then we have 4 ones again F. So then we have all zeros. So 0 is represented. So the final register configuration that is used to display 0 in the 7 segment display is 0x F0 3F afterwards 4 zeros. So this is a register configuration that is used to display 0. Next we shall see how to display 1 in the 7 segment display. So to display 1, only B segment and C segment should be activated. So that's why I have written 1 across B and C, and 0 is written across all other pins. And I have written 1 across all the 4 units because I'm displaying 1 across all the, I'm using all the 4 display to display 1 in the 7 all in all these 4 7 segment display. So that's why I've written 1. So if we convert these to an hexadecimal representation, 4 ones constitutes F. Then we have 4 zeros, 0 will be represented. Then we have again 400. So then we have 0110. Here we are activating only the C pin and B pin. So C is associated with 18th pin, B is associated with 17th pin. I'm activating only these 2 pins. So the pin configuration is 0110. So if we convert that to the hexadecimal, then 6 will be the hexadecimal representation. Then we have 4 zeros, which means that, so the register configuration to display 1 is 0x F00640. So likewise, let's see the register configuration to display 2. So here C and F are in off state, and all other segments should be on. So that's why I have written 0 across C and 0 across F. So then 1 across all the 4 units. So this will be 0xF05B 4 zeros. Next, let's see the register configuration to print 3. So here, except F and E, all the segments should be on. So I have written 0 across E and F, and I have written 1 across all other segments. Then the final register configuration is 0x F04F4 zeros. So let's see how to display the 4 as the hexadecimal number on the 7 segment display. So here segment A should be off, and segment E and D should be in off mode. So that's why I have written 0 across segment A, 0 across segment D, and 0 across segment E, and I have written 1 across all other segments. And I have also have written 1 across all the in all the 4 units, which means that 4 will be displayed in all the 4 7 segment display. So the final register configuration to display 4 on the 7 segment display is 0x F06640. Okay, so let's see how to display 5. So to display 5, segment B and segment E should be in low state. So that's why I have written 0 across segment B and E. So the final binary representation is 4 ones. Then here we have 0110. 0110 is 6 in hexadecimal. Then we have 1101. 1101 is D in hexadecimal. So the final representation or the final register configuration is 0xF0 6D, after that 40. So this is the final register configuration which we need to use to display 5 on the 7 segment display. So next, let's see how to display segment 6. So let's see this segment 6. So how the 6 will be displayed on the 7 segment display. So here, to display 6, all the segments should be on except B. So that's why I have written 0 across B, and I have written 1 across all the other segments, and I have written 1 across all the 4 units. So the final representation is F0x F07D 4 zeros. So this is the register configuration which is used to display 6 on the hexadecimal. So let's see how to display this 7. So to display 7 on this 7 segment display, we need to activate A, B, and C. All other segments should be in deactivated mode. So that's why I've written 1 across segment A, B, and C, and I have written 0 across all other segments. So the final register configuration is 0x F000740. So this is the final register configuration. So let's see how to display it. So to display it, all the segments should be on. So we need to activate all the segments, and we need to activate all the port pins. So that's why I've written 1 across all the 7 segments, and I've written 1 across all the 4 units. So the final register configuration is F07F followed by 4 zeros. So then 9. So to display 9, only all the segment should be activated except E segment. So that's why I have written 0 across E. So then the final register configuration is 0xF06F40. Then to display the character, so to display the character A, so we need to activate all the segments except D. So that's why I have written 0 across D here. So the final register, the binary representation for this is 0 triple 1 in hexadecimal is 7. Then we have again 0 triple 1. So the 0 triple 1 in hexadecimal is 7. So the final register configuration is 0x followed by F07740. Then to display B, so we can display lowercase b on the 7 segment display. So here the segment, all the segments should be on except the segment A and B. So A and B should be in a low state. So that's why I have written 0 across segment A and B, and all other segment I have written 1 across all other segments. So the final register configuration to display B is F07C40. So let's see how to display C. So to display C, segment A should be high state, segment F should be in high state, segment E should be high state, and segment D should be in high state. So that's why I have written 1 across A and 1 across D, 1 across E and F, and have represented 0 across B and 0 across C, and also have 0 across G. So I have written 1 across all the 4 units, which means that I am displaying C in all the 4 7 segment display. So the final register configuration to display C is 0x F03940. So let's see how to display D on the 7 segment display. Again, we cannot display the uppercase D, we can display lowercase d on the 7 segment display. So here segment, all the segments should be in high state except the segment A and F. So that's why I have written 0 across A and 0 across F, and 1 across all the other segments. So the final register configuration is 0x F05E40. So this is the register configuration in hexadecimal format. Then let's see how to display E. So if you want to display E on the on the 7 segment display, so all the segments should be high except B and C. So that's why I have written 0 across B and C, and I have written 1 across all other segments. So if I convert 0 triple 1 to hexadecimal, then 7 will be represented. So if we convert 10001 to hexadecimal, then 9 will be the hexadecimal number. So the final register configuration to display E on the 7 segment display is 0x followed by F07940. So to display F, so this is the last character which we can display on the 7 segment display. So here segment B, C, D. So these 3 segments should be in low state. So that's why I have written B, 0 across B, C, and D, and 1 across all other segments. And also I represented 1 across all the 4 7 segment display. So the final register configuration to display F on the 7 segment display is 0x F071 40. So this is the final register configuration which is used to display, or which is used to set the port pins to display F on the 7 segment display. So hope you have understood all the register configuration to display the alphanumeric characters from 0 to F. So then we have a program. So I will explain this program in the Keel IDE. So when I open it, when I execute when I show you the execution on the Keel IDE. So the result is, after executing the program, the result is after dumping the code, which means that after dumping the hex file to the microcontroller. So when we switch on all 4 7 segment displays, so there is an on and off button. So I have showed you previously. So there is an on off button. So if you on all these 4 7 segment display, then the hex digits from 0 to F will be displayed. So in the other video, so in the next video, in the second video, so I will show you the execution. So where you can see how the hex characters that are displayed in all the 4 7 segment display. So next I will show you how to execute the program on the Keel IDE, and I will also explain the program there only. So I will close this. So there is a Keel Microvision 4 on the desktop. So you need to double click on this. It takes some time to get open. Okay, so when you open Keel Microvision 4, so if there are any programs, so if there are any previous programs, then you need to go to project here. Then you need to select close project. So here I don't have any previous programs here. So I will straight away go on I will straight away go to create the project. So to create the whenever you want to execute the program on Keel Microvision 4, first you need to create the project, then you need to create the file. Okay, first I will create the project. I will show how to create the project on Keel Microvision 4. So go to select, click on the project, then click on select new Microvision project. So then it will ask the root folder to save the project. So as I told earlier, so first you need to create one folder on the desktop, then you need to and you need to select that folder to save the project. So here I have created a prog folder on the desktop. So in that folder I am naming the project name as 7 segment. So you can give anything, project name can be anything without extension. Don't give any extension. Then I click on save. So after that, so there is a search bar here. So in this search bar, you need to type LPC2148, LPC2148. So this is the microcontroller we are using. This is the microcontroller which we are using in our lab. So select this LPC2148, then click OK. So then it will ask a copy startup.s to project folder and add file to project. So yes, you need to click on S because we need this startup.s folder, because all the library files or all the library functions are declared in this startup.s. So to execute all the part B programs or to execute all the hardware programs, we need a predefined instruction. So that are stored in the that are declared in the startup.s. So then you need to click on S here. Again S. So after this project has been created, now we need to create a file to type the program. So go to file here, select new. Okay, so here you need to type the program. So after typing the program here, so you need to save the file. Go to file, save. So okay, so now you need to give a file name. So I will give a file name as a 7.c. So while saving the file should be saved with an extension .c, because we are writing C program into this file. So that's why the file extension should be .c. Okay, so here you need to give a file extension as .c, then click on save. After this, we need to link this file to the project. So let's see how to link this file to the project. So here we have a project dialog box in the left hand side. So under the project, so we have target one. So click on this plus sign. Under the target one, we have source group one. So again, click on this plus sign. So here already we have startup.s. Another file need to be included here. So that is a 7.c. Okay. So click on this source group one, right click, select add existing files to group source group one. So after that, you need to select the stepper motor, or sorry, 7. So this is the file, this is the C file which we have created, right? 7.c. So you need to select this 7, then click on add. So when you click on this add button, so here you can see 7.c has been added to the source group one. Okay, so there are two files here. One is startup.s. Startup.s has the library functions or predefined instructions. Then 7.c, where you have written your program 7.c. So I will explain the program. So here again, I'm using the header file as #include LPC2148 X.h. So again, here X represents the microcontroller version. So here we are using LPC2148. So in general, you can represent it this as X.h. H represents the header file. Okay. So this is the header file which I'm using, because all the ARM instructions like IO clear, IO set, pin select, IO direction. So all these instructions are defined in this #include LPC2148X.h, and this header file is there in the startup.s folder. So after that, we have a delay function as usual, same delay function which I have written in this program. So here delay function with one parameter called x. So here at the function calling, I will be sending one data, so that data will be received by this parameter. So then we have one I should use the two for loops uh, to get the delay in the microcontroller. So here unsigned int ing, so then I'm using I'm initializing I to 0, and is less than x, where x is nothing but the data which you send at the function calling. So here in this program I'm sending 5000. Here 5000 is in microseconds. Okay, 5000 is in terms of microseconds, so that will be received by x. So the I loop will go on executed till that 5000. So when it exits, so then it will come out of the for loop. Then inner for loop is for j is equal to 0 and j is less than 1275. So here 1275 is a constant number. By trial and error, I have selected this number. Then j will go on increment. So while iterating this or while executing this for loop, we don't have any other statements which need to be executed. Okay, so we don't have any other statements which is there in the body of the for loop. So that's why I've written semicolon at the end of the second for loop. So this is what the delay function is. So why this delay is used, and that first on the 7 segment display, 0 digit will be displayed. After that, 0 will be erased, some delay should be applied. So after some amount of delay, the next digit like 1 will be displayed. Okay, now after displaying 1, that 1 will be erased by input output clear function. Then after some delay, 2 will be displayed. So which means that to actually to clear, so to visible, to clearly visible all, to clearly uh, see all, to if you want to clearly see all the digits, then we need to give some delay in between the numbers which is displaying on the 7 segment display. So that's why we are using this display function. Then going with the main function. So on main function, the first statement which statement what I'm using is IO direction. I'm setting the output direction to the register configuration, that is 0xF0FF000, which means that I'm activating all the pins. So F0FF000. So here in the PPT, I have not taken DP. So but here I have considered DP. So if we consider DP, then it will be represent, the register configuration is represented as F0FF40. So in the register configuration which I have shown in the PPT, so there I have not considered the DP segment, but here to set the direction I'm considering the DP segment. So if we consider the DP segment, then the register configuration is 0x followed by F0, where this F represents this F represents to display the numbers on all the four hexadecimal, then we have 0, then double F represents the 8 segments which need to be activated to display the characters. So then we have a while loop, which means that after displaying the numbers from 0 to F, so again it will start from 0. So again it will start from 0 to display that on the 7 segment display. So that's why I have taken, I'm writing all the codes inside the while loop. So here is an infinite while loop, which means that infinite times the characters 0 to F will be displayed. So then first instruction is IO clear. So before displaying any number, first I am clearing all the pins, and after clearing all the pins, I am setting IO set 0. Why this 0 is represented after IO set and ಹೇಳಿದ್ರೆ, because here I'm using, I'm making use of only port 0. So that's why I'm writing 0, which means that I'm writing this register configuration only for the port 0, not for port 1. So why I'm not using port 1 and ಹೇಳಿದ್ರೆ, in port 1 I'm not making use of any pins. So that's why I'm not using port 1. I'm only using port 0. So here I'm using the register configuration. I was at 0. So this is the register configuration to print 0. So this is the code to print 0. After that, some delay will be applied. After some delay, again the previous data will be cleared by 0x F0 double F0, which means that all the 8 pins, including the display unit, all the 8 pins, including all the 8 segments, including the 4 display, all this will be cleared. After that, the new data will be, the new register configuration will be set by the IO set 0 instruction. So this is the register configuration to print 1. Then we have a delay. So like this. So this is the code to print 2, and this is the code to print 3. Then we have a code through to print 4. So like this, we have all the codes which is used to print the different alphanumeric characters from 0 to F. So that's it. So why delay is used and delay is used in between the numbers, so in between the characters which is displaying on the 7 segment display. So basically to clearly visible all the characters on the 7 segment display, so we are using delay function. So here I'm passing 5000. 5000 is the numerical value which represents in which usually represents in microseconds. So that's what I'm passing that in the function calling. So this is how the program is. So then we need to do some settings to execute this program. So what those settings and again select this target one which is there in the project dialog box. So right click on target one, select options for target one. So here you need go to output. So then you need to check on this create hex file, which means that while compiling and after compiling the program, the hex file need to be created. So why hex file and again the microcontroller accepts the input from the general purpose system through the hex file. So through the hex files only. So that's why we need to that's why hex file need to be created. So you need to check on this create hex file. After that, we have a linker option. So here you need to select use memory layout from target dialog box. Then click on OK. So after this, you can rebuild the program. So when you click on this rebuild, the program will be compiled. The header files will be linked. The header files will be linked. After that, the hex file will be created. After successful compilation with the 0 errors, the hex file will be created. So click on this rebuild option. So it takes some time. Yes. So we have a 0 errors here, and so the X file also been created. So now we need to dump this X file to the microcontroller. So how to dump the hex file to the microcontroller and so again we need another application for that to dump the hex file to the microcontroller. So minimize this, open Flash Magic. Okay, double click on this Flash Magic. Okay, so this is the Flash Magic window. So here we need to select the device, we need to select the COM port baud rate interface. So all this need to be done. So then go to browse here. So go to the root project folder which you have created. So in the desktop, I have created prog. I'll select that folder. Here you can see 7segment.hex. So this is the hex file which has been created. Which has been created after successful compilation with 0 errors. So select this hex file, then click on this open. So after that you can click start. Okay, so when you click on the start, so after successful dumping the file to the microcontroller, when you switch on all the 4 displays, the characters from 0 to F will be displayed on the on all the 4 7-segment display.
So it is still in processing. So once it get processed, so the entire file has been dumped to the microcontroller. So this is the microcontroller. So in this, these are the 7-segment display. So these are the 7-segment LEDs. So here we are making use of the first one. Okay, only first one we are making use it. So here there are switch on and off button. So I will switch on this. So once we switch on this, all the digits from 0 to F, so that will be displayed. So you can see here D0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So again it will start from 0 to F, because we are using while loop in our program, which means that it is go on executing, or which is go on repeating with the digits starting from 0 to F. So this is the output of the 7-segment display.